Alright, hi guys. So we are starting a new unit on rational functions and rational equations today. And so whenever you hear me use that word rational, that just means something with a fraction in it. So you're going to notice every single one of these examples that we deal with today has a fraction. So the first thing that you probably learned how to do with fractions when you were in like 3rd and 4th grade and you were really tiny was you probably learned how to reduce them. And that's actually where we're starting today. Before I ever graph these fractions, I've got to see if I can reduce them. So in example 1, I have a 2, an x, and a 5. Well, there's nothing that goes into all three of those, so there's nothing in common I can pull out. And I also can't do the x method because there's no x squareds there, so I can't factor it. So in this case, on example 1, I can't simplify that fraction. So I go to my second question, which is what are my asymptotes? And that's a really big word. But an asymptote, guys, is basically a fence. So just like you have a fence in your backyard, and you can get as close as you want to that fence, but you can't go through it, okay? An asymptote is kind of like an imaginary line on a graph, and your graph's going to get really, really close to that line, but it's never actually going to touch it or cross it. That's an asymptote. So when I'm dealing with fractions, there's only one thing that I can't have. I can't have a 0 in the bottom of my fraction. So the way that I find my asymptotes is to say, okay, where does the bottom, so in this case, where does x minus 5 equal 0? Whatever my answer is, that's my asymptote. That's what my graph can't be. So when you solve this equation right here, you get x equals 5. That's the only thing that x cannot be. You could plug in a million, you could plug in negative 25, whatever you want to. You just can't plug in 5. So once you've got your asymptotes, you're ready to go ahead and graph this. So the first thing you'll do, since I know that x equals 5 is my asymptote, is you'll find where x equals 5 right here on your graph, and you're going to draw a line straight up and down through that point. And it'll be dotted because, again, it's imaginary. It's not actually there. We just put it there so we know where the graph's going to stop. The next thing that I need to do is actually draw in the graph, and that's where my calculator comes in really handy. So we have y equals, and alpha y equals 2 over x minus 5. And when I go look at the graph, I'm not going to be super specific, okay? It doesn't have to have a bunch of points on it, but I am going to give an idea of what the picture looks like generally. So when I go look at the picture, I notice it runs right along the x-axis, but then it gets to x equals 5 and it dips down. And on the other side, it does something very similar. It gets right up close to x equals 5, but then it veers away from it. And there's my graph right there. I'm done. And if you notice, your graph splits around your asymptote. That's what it should do every time. Okay? So let's say I go look at example 2. Again, the first thing I ask myself, can I simplify that fraction? And in this case, the answer is yes, because I'm dealing with quadratics. They're things that I can probably factor. So I'm going to start by factoring the top. Okay? So I am looking for two numbers that multiply to negative 144 and add to 0. Well, that's 12 and negative 12. Then I'm going to go factor the bottom. So on bottom here, I'm looking for two numbers that multiply to negative 24 and add to 10. So that would be, let's see here, that would be 12 and negative 2. Okay? So what I'm going to do now that I have my factors, I'm just going to rewrite this equation in factored form. So instead of having x squared minus 144, now I've got x plus 12 and x minus 12. And on bottom, instead of having x squared plus 10x minus 24, I now have x plus 12 and x minus 2. Okay? So something you should notice right here, you've got an x plus 12 on top and on bottom. Well, now I can reduce this fraction. those get to cross out, okay? So when I'm thinking about what are my asymptotes, I am only worried about where does x minus 2 equal 0? What can x not be? That x minus, or excuse me, that x plus 12 is gone now because I've crossed it out. So my only asymptote is going to be the answer to this equation right here. Where does x minus 2 equal 0? Well, when you solve that, you get x equals 2. Okay? So something I do want to mention right here, you will see questions sometimes that ask you what x can't be. If they ask you what x can't be, you tell them 2 and negative 12, right? Because if I plug a negative 12 here on the bottom, it would still give me 0. So you've got two things that x can't be. But if they ask you what the asymptotes are, it's only the stuff that didn't get crossed out on the bottom. Okay, so two different questions there. So now I'm ready to go and graph my rational function. And the first thing that I graph is my asymptote. So I go find where x equals 2, right here, and I draw a line straight up and down through it. Everything else my calculator will do for me. So once I have drawn in my asymptote, I go to y equals in my calculator, and I'm going to type in x squared minus 144 over x squared plus 10x minus 24. And then it will give me what my picture should basically look like. So here's what it looks like. So it's above the x-axis, and it goes like this. And then, oops, I accidentally went too far there. I should not have crossed that asymptote. I apologize. So it's going to get really close to that asymptote and shoot up. And then the same thing on the other side. This side shoots down. Okay? And there's my graph. All right, our very last example here, when I look at number 3, again, I'm going to have to do some simplifying, okay? So I start with the top. I can't do my x method here because it's not a quadratic. There's no x squared. But what I do notice is 2 and 8 have something in common. I can pull a 2 out of both of those. So I'm going to go ahead and do that on top. Divide them both by 2. And when I do that, that leaves me with x minus 4. Now I'm going to go and factor the bottom. And again, this time, there's nothing in common. But because it's an x squared, I can do my x method. So I'm looking for two numbers that multiply to negative 35 and add to negative 2. And when I think that through, that would be negative 7 and 5. So all that I'm going to do now, instead of writing x squared minus 2x minus 35, I'm going to replace it with its factors. I've got x minus 7 and x plus 5. Okay. So when I look at this fraction, there's nothing I can cross out. There isn't an x minus 7 on top, and there isn't an x plus 5 on top. So here's what that means. If I can't cross anything out, that just means I have two asymptotes. So now I want to know, where does x minus 7 equal 0? And also, where does x plus 5 equal 0? Okay. So when I solve those equations, I get x equals 7 and x equals negative 5. So once I have my asymptotes, now I'm ready to graph. So I'm going to go find both of these points now. So here's x equals 7 all the way over here on the right. You'll draw a line through it. And then your other one is x equals negative 5. You'll draw a line through it. Okay. So I've got two fences here. My graph is going to fall in between and around those two asymptotes. Once I've got my asymptotes, I go to my calculator and I type in 2x minus 8 over x squared minus 2x minus 35. And it will give me the rest of that picture so I don't have to try to figure that out in my head. So if you notice, when I had one asymptote, I had 2 pieces. Now that I have 2 asymptotes, I have 4 pieces. So keep that in mind. The more asymptotes you have, usually the more pieces you're going to have to this graph. Okay? So you all have a matching activity to do today. Make sure you show me your work and go ahead and get started.